Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Agus Kumaiti. I came from Automation Engineering Department, Politeknik Perkapalan Negeri Surabaya. And in here, I would like to explain about my latest research with the title of Automatic Hull Fracture Detection System using Template Matching. Keel fin is a point on the keel of the ship that serves to increase the transfer friction of the ship. It can increase the stability of the ship. Corrosion or crack on this part can affect the movement of the ship being unstable. So then we are offering a solution by developing a hull fracture detection system using template matching feature. Template matching was chosen because of the ease of computing over and the simpler concept. The more dataset templates are used for train will increase the accuracy for detecting the fracture. Actually, the Haar cascade is a kind of Violet-Jones method which combines of four main cases. The first is Haar-like feature, the second is integral image, the third is AWS learning algorithm, and the last is cascade classifier. The computation of this system is very fast because it only depends on the number of pixels in a square, not every pixel value of an image. We can calculate the Haar-like feature by finding the difference from the number of pixels of the area inside a square or rectangle. An example of Haar-like feature is presented in figure 2 below. Haar-like feature value, or F-Haar, was obtained from the sum of the difference of dark area, or F-black, against the sum of the difference of bright area. Integral image is a technique for quickly calculating feature values by changing the value of each pixel into a new image representation. The AWS learning algorithm is used to improve classification performance with simple learning to combine many weak classifiers into one strong classifier. A weak classifier is a correct answer with an inaccurate level of truth. The cascade classifier is a method for combining complex classifier in a multi-level structure that can increase the speed of object detection by focusing on only possible image areas. In this study, there are 7 stages to create the Haar cascade dataset. For the beginning, we are creating a positive image. This step can be done by making some positive images of .bmp format and put them in positive or raw data. More images more precision the system in order to detect the object. The second step is creating a negative image. By default, there will be 200 or more negative image background in the negative folder. The third step is negative info file. After adding the negative samples, the process continues to create the negative info. The fourth step, positive info file. We are cropping the area as object for all positive image. The fifth step is creating the sample. This step will make a positive vector file in vector folder. The sixth step is hard training. And the last step is converting the hard training result to XML. In this case, we use 200 datasets for positive image and 200 datasets for negative image. This research has successfully proven that through digital image processing technology, the visual inspection process will become easier with the help of a digital camera. For wider application and to apply this method to a mini PC or portable devices, it is necessary to add template datasets with various types of crack images to maximize the performance. We are applying some testing scheme by changing the thresholding values. Figure 5 shows that a thresholding value equals to 1, the system is unable to detect cracks in the hull or build skill of the ship. At 0.99, the system shows an improvement, with the percentage of success equals to 90%. A constant result is shown in thresholding 0.9 to 0.98, with the percentage of success reaching 95%, and success reaching 100% when the thresholding value is equal to 0.89. We can conclude that the template matching method using HAR Cascade has been successfully applied to detect cracks on the hull and shots of ship. The accuracy rate of success in the study varied by 95% for the range of thresholding values at 0.9 to 0.98 and 100% at the thresholding value of 0.89. Further studies need to be carried out on the verification study of hull fracture and the development of this research, such as the testing of ship crack detection systems in underwater imagery, so as to facilitate the underwater visual inspection process before the docking process is carried out. This is the end of my presentation, and thank you.